This is the August 11, 2021 Reid-Hillview Airport Airborne Lead Study San Jose Community Meeting, 6 p.m. by virtual teleconference. Good evening. Thank you for your patience. This is Peggy Doyle, Deputy Clerk for the County of Santa Clara, with announcements for tonight's Reid-Hillview Airport Airborne Lead Study San Jose Community Meeting. This meeting is being recorded. The meeting is scheduled to end by 9 p.m. and there will be a brief break after the presentation. Simultaneous Spanish and Vietnamese interpretation are available. To access the audio feed for either language, click the Interpretation tab under the globe icon at the bottom of your Zoom screen. From there, select Spanish or Vietnamese. Clicking the same Interpretation tab will return you to the English audio feed where you can select English or off. If you do not turn on interpretation, you will hear the entire meeting in English with consecutive translation of Spanish and Vietnamese comments and questions. American Sign Language translation will be visible throughout the meeting. If you would like to enable captioning, click the Live Transcript tab at the bottom of your Zoom screen. From there, you can select subtitles that will appear on the bottom of your screen. You can also select Full View Transcript for a live transcript that will appear on the right side of your screen. These announcements will now be translated into Spanish and Vietnamese. Rosario, if you would provide a Spanish translation.
Buenas tardes, mi nombre es Peggy Doyle y soy representante adjunta del Condado de Santa Clara con unos anuncios para esta reunión de San José con el estudio de plomo en el aire del aeropuerto de Reid-Hillview. Esta reunión se va a grabar. La reunión está programada para terminar a las 9 de la noche y habrá un breve descanso después de la presentación. Hay interpretación simultánea disponible en español y en vietnamita. Y para acceder a ella pueden hacer clic en el botón de interpretación en la parte de abajo de la ventana de la pantalla de Zoom. Seleccione español o vietnamita. Al hacer clic en interpretación también regresará al audio en inglés, en donde puede seleccionar inglés o apagado. Si no activa la interpretación, escuchará toda la reunión en inglés con interpretación consecutiva en las preguntas en español y vietnamita. Está disponible la interpretación en señas en inglés durante la reunión. Si quiere habilitar los subtítulos, por favor vaya a la parte inferior de la pantalla y haga clic en CC, y también se puede habilitar la transcripción de vista completa.
Hung On, if you would translate to Vietnamese.
Xin chào, đây là Peggy Doyle, Phó Thư ký quận Santa Clara với thông báo về buổi họp cộng đồng trưởng nhóm nghiên cứu hàng không sân bay Reid-Hillview tối nay ở San José. Cuộc họp này đang được ghi lại. Cuộc họp sẽ dự kiến sẽ kết thúc trước 9 giờ tối và sẽ có một khoảng nghỉ giải lao ngắn sau mỗi giờ. Có thông dịch đồng thời tiếng Tây Ban Nha và tiếng Việt. Để truy cập nguồn dữ liệu âm thanh cho một trong hai ngôn ngữ, hãy nhấp vào thanh phiên dịch bên dưới Interpretation, biểu tượng là quả địa cầu ở phía cuối màn hình thu phóng của quý vị. Từ đó chọn tiếng Tây Ban Nha hoặc tiếng Việt, Spanish hoặc là tiếng Việt, nhấp vào cùng một thanh công cụ thông dịch Interpretation để đưa quý vị trở lại nguồn cấp dữ liệu âm thanh bằng tiếng Anh. Nơi đó quý vị có thể chọn tiếng Anh hoặc là tắt tiếng Anh để có thể nghe phần tiếng Việt được rõ ràng. Nếu quý vị bật thông dịch Interpretation, quý vị sẽ nghe thấy toàn bộ nội dung cuộc họp bằng tiếng Anh này với bản phiên dịch trực tiếp bằng tiếng Tây Ban Nha hoặc tiếng Việt tùy theo lựa chọn của quý vị. Bản dịch ngôn ngữ ký hiệu thông âm kiểu Mỹ sẽ biểu hiện trong suốt cuộc họp. Và những thông báo này sẽ được dịch sang cả tiếng Việt và tiếng Tây Ban Nha cho quý vị. Xin cảm ơn. Thank you.
Good evening and welcome. I'm Sylvia Gallegos. I am a Deputy County Executive with the County of Santa Clara. I'd like to welcome you tonight to our community meeting to review the county study of lead emissions from general aviation airplanes at Reid-Hillview Airport. Before I explain the purpose of the meeting, I would like to provide background on the study. In 2018, our Board of Supervisors, who are our elected officials, asked staff to prepare a study to learn whether airplanes using lead-based fuel contributed to lead exposure in children who live nearby. After nearly a year of work, our researcher is prepared to present his findings. The purpose of tonight's meeting is to have our researcher, who I will introduce later, explain his findings and allow everyone to ask questions about the study. Tonight's meeting is not to discuss the future of the airport. I would ask you to make your comments to the Board of Supervisors meeting next Tuesday, August 17th at 6 p.m., where you can learn what staff proposes to do about the study's findings, and you may share your comments directly with our elected officials. After the study is presented, we will open up the meeting for people to submit questions in writing. And at the end of the meeting, with the time remaining until 9 p.m., we will invite people to ask questions orally if they're not able to access the written question process. So now I'd like Peggy Doyle to explain how you may submit your questions in writing.
Thank you, Sylvia. If you would like to submit a question, click on the Q/A or Q&A tab at the bottom of your Zoom screen. A window will open with a space at the bottom to type your question and send it. If you would like to see questions that are also electronically answered, select the All Questions tab. For example, one moment, please. I will set up an example momentarily. The question will be, where can I find a complete airborne lead study and tonight's presentation? And that information will be provided. Another question will be, how can I attend the August 17 Board of Supervisors meeting when they discuss the study, and that information will be provided. If you continue watching your question and answer screen, you will see that information come up.
So now I would like to introduce County Supervisor Cindy Chavez, who would like to make a couple of comments before I introduce the researchers. And she is available on your screen. Thank you, Supervisor Chavez.
Thank you, Sylvia. And I want to say thank you to the staff. I know tonight's going to be very, very informative. We have over 300 people who've joined us tonight. So I know this is of significant interest to all of our community. One thing I just wanted to reinforce is that this is an opportunity to hear from the researcher and our staff and make sure that every question you possibly could be interested in gets answered tonight as best we can do it. And so I do really want to encourage folks, as you listen, to jot your questions down and get them into that Q&A. I realize it's a long meeting from 6 to 9. The study is going to take a bit of time to get through. Then everybody will have a brief break, and then we'll just be ready to answer questions. I do want to say thank you again for taking time away from your families to learn about this really, really important issue. Thank you.
And now I'd like to introduce the two researchers that will be presenting tonight. First, Dr. Sammy Zaran. He is a professor of demography and associate chair in the Department of Economics at Colorado State University. He also holds a joint appointment in the Department of Epidemiology with the Colorado School of Public Health and serves as the senior academic for the county's Airborne lead study. He's also the co-founder of Mountain Data Group, which officially prepared the study. Dr. Zaran's 2017 study on the effect of lead-based aviation gasoline on blood lead levels in children examined data that linked blood lead from over 1 million children to 448 nearby airports in Michigan Across a series of tests and adjusting for other known sources of lead exposure, the research found that children's blood lead levels increased in proximity to airports with piston engine aircrafts. And this is how we came to learn of Dr. Zaran and asked him to prepare this study for the county. The second researcher we have here is Dr. Bruce Lanphier. He is a public health physician and a pediatric epidemiologist specializing in environmental exposures, including lead. Dr. Lanphier has an MD from the University of Missouri and a master's in public health from Tulane School of Public Health. He is currently a professor in the Faculty of Health Sciences at Simon Fraser University and a clinician scientist at the Children's Hospital Research Institute of the University of British Columbia. Dr. Lanphier's work focuses on the impacts of fetal and early childhood exposure to environmental toxic chemicals, and he's published numerous studies relating to the effects of exposure to lead in childhood. And some of his findings are cited throughout our staff report. And with that, I'm going to turn it over to Dr. Zaran.
Thank you, Sylvia. I'm going to share my screen now and hope that all can see. Can everyone see?
We can see.
I want to thank the county for arranging this important evening, allowing us to share what we have learned. I'd also like to thank all persons in attendance. We look forward to your questions, comments, and hope to learn things from you, your lived experiences, and concerns. As you might imagine, we've gotten many questions and comments from the community upon release of the report. In addition to our prepared remarks this evening, we have performed additional analyses to address many thoughtful questions from the community that, time permitting, we could possibly share in the Q&A portion of this evening. What follows is an abbreviated summary of the report. The report has been described to me as a difficult document. With that in mind, in this presentation, where possible, we have limited the use of technical language and expunged the presentation of statistical equations and tables peppered with coefficients. Some of the technical language is inescapable, and my apologies in advance for that. All that said, the presentation will mostly involve graphics that summarize the many technical challenges involved in the study. I will also speak a bit slower than normal to enable translation services provided at this event. While knowledge of the toxic effects of lead stretch back millennia, the evidence amassed by modern science indicates that children exposed to lead suffer substantial, long-lasting, and possibly irreversible negative health, behavioral, and cognitive outcomes. Numerous studies have linked elevated blood lead levels in children to cognitive and intellectual impairments, poor academic achievement, and higher risk of attention deficit and hyperactivity disorders. Importantly, the relationship between child cognitive ability and blood lead is nonlinear. By that we mean the measured loss in cognitive ability is steeper at lower blood lead levels. Consider the following graphics. In graphic A, we have from a published study by Dr. Lamphere et al., 2005, illustrating the notion that the loss in intellectual ability is steeper at lower blood lead levels. On the horizontal axis, we have child blood lead level, here measured in micrograms per deciliter. On the vertical axis, we have child IQ, an imperfect but widely used indicator of certain kinds of cognitive ability. I want you to note how the addition of 1 microgram of lead in a child's bloodstream produces greater loss in measured ability at lower as opposed to higher blood lead levels. If you fix your eyes here, you could see that if you were to add a microgram, moving from 0 to 1 to 2, that the loss in ability is significantly steeper than if we were to add an additional microgram to a child that already has substantially higher blood lead levels. This loss in ability from exposure to lead in early childhood echoes through a child's academic life. Consider graphic B from a published study by Miranda et al., linking child blood lead levels at age 2 to performance on standardized tests in 4th grade, many years later. Again, we see the signature non-linear effects of lead exposure. The loss in performance is steeper at lower blood lead levels in both reading comprehension and mathematics. Studies by scientists like Lamphere and Miranda have caused various health organizations to conclude that there is no safe level of lead in a child's body. I quote, "Even low levels of lead in blood have been shown to affect IQ, ability to pay attention, and academic achievement." The FAA fact sheet is more detailed. All forms of lead are toxic if inhaled or ingested. Lead can affect human health in several ways, including effects on the nervous system, red blood cells, cardiovascular and immune systems. Infants and young children are especially sensitive to even low levels of lead, which may contribute to behavioral and learning problems and lower IQ. Children have increased sensitivity due to their developing nervous systems. Now, it might be tempting to assume that lead exposure in the United States is a legacy problem. After all, the blood lead levels of children in the United States have declined substantially over the last 4 decades, coincident with a series of regulatory actions that expelled lead from paint, plumbing, food cans, and automotive gasoline. Most effective among these interventions was the phase out of tetraethyl lead from automotive gasoline induced by provisions of the Clean Air Act. While tetraethyl lead is no longer used as an additive in automotive gasoline, it remains a constituent in aviation gasoline used by an estimated 170,000 piston engine aircraft. These aircraft consume tens of millions of gallons of lead formulated gasoline annually, with lead emissions from this consumption accounting for about half to 2/3 of all lead emissions in the United States today. The deposition of lead from these aircraft may be an exposure risk to the estimated 16 million persons residing within 1 kilometer of airports that service these aircraft. While many studies have linked aviation gasoline use to elevated atmospheric lead levels in the vicinity of airports, to date, only 2 studies have explicitly linked aviation gasoline to the blood lead levels of children residing in the vicinity of airports. In a study involving over 125,000 observations across 6 counties and 66 airports in North Carolina, Miranda et al. Reported a striking correlation between child blood lead levels and airport proximity, with children at 500 and 1,000 meters, about a half mile, of the airport at greatest risk of elevated blood lead levels. With a team of colleagues in a study involving over 1 million children and 488 airports in Michigan, we found the child blood lead levels increased with proximity to airports, increased with piston engine aircraft traffic observed at a subset of airports, increase in the percent of prevailing wind days drifting in the direction of a child's residence, and declined measurably among sampled children in the months after the tragic events of 9/11, following from measured reductions in traffic. Mountain Data Group and affiliated scientists were asked to assess whether the blood lead levels of sampled children are statistically associated with exposure to lead from aviation-related sources, independent of other sources of lead. Specifically, we set out to test whether the blood lead levels of sampled children near Reid-Hillview and San Martin airports are correlated with child residential proximity, child residential direction or near angle, and the quantity of piston engine aircraft traffic. What follows is a presentation of results pertaining to Reid-Hillview Airport. Only 68 blood samples were taken from children proximate to San Martin Airport in the last 10 years, prohibiting credible statistical analysis. Now, we'll describe the various data sources deployed in the study, as well as the various measurement decisions made to capture exposure risk to lead-formulated aviation gasoline. Blood lead sample data are from the Childhood Lead Poisoning Prevention Branch of the Colorado Department of Public Health. Blood lead samples are collected from children during visits to healthcare providers. Laboratories send test outcome data to the Lead Poisoning Prevention Branch. We queried their databases for various records with an indication of residence in Santa Clara County, a date of blood draw occurring within the last 10 years, a date of birth on the sampled person, and a reported blood lead value, restricting to children 18 years of age and under, residing within 1.5 miles of Reid-Hillview Airport, and observed over this 10-year time span. We arrived at 17,241 blood lead sample observations amenable to statistical analysis. The main outcome variable of analytic interest is blood lead level, measured in micrograms per deciliter of blood. Among children satisfying our inclusion criteria, the average blood lead level was 1.83 micrograms per deciliter. About 1.7 and 3.2% of sampled children present with blood lead levels in excess of 4.5 and 3.5 micrograms per deciliter, respectively. For context, our pre-industrial ancestors had blood lead levels in the range of 0.16 micrograms per deciliter, more than 100-fold lower than a typical child around Reid-Hillview. Given that the bulk of lead emissions are released during departure phases of the landing takeoff cycle, we capture child proximity by calculating the distance from a child's residence at the point of blood draw to the northwest tip of Reid-Hillview Airport. As with previous research, we analyze the residential distance effect continuously and by division into 3 orbits of risk: less than a half mile to 1 mile, and 1 to 1.5 miles from the airport. Now, insofar as avgas exposure is a genuine source of risk, children residing closer to the airport should present with higher blood lead levels. Moreover, as we will show later, children that reside in these different orbits of risk are statistically similar with respect to observable factors that may simultaneously govern blood lead outcomes. This figure illustrates the measurement logic. Over our 10-year window, we observe about 1,000 records in that inner orbit. Again, insofar as aviation gasoline exposure is an independent source of risk, and other things held equal, sampled children in that nearest orbit should present with higher blood lead levels as compared to children in outer orbits. Airport proximity by itself is an imperfect measure of aviation gasoline exposure risk. The fate and transport of lead emissions depend on the direction of prevailing winds. We assign each sampled child a near angle to Reid-Hillview Airport corresponding to the 4 cardinal directions of north, south, east, and west. In this radial plot, we summarize the behavior of wind at Reid-Hillview over the last 10 years. Each wedge displays the percentage of wind days that emanate from a defined direction. Here we see that the winds originate overwhelmingly from the west-northwest. Insofar as aviation gasoline exposure is a source of risk, then, children residing in that eastern wedge of the space should present with higher blood lead levels. The volume of piston engine aircraft traffic varies meaningfully between airports and within an airport in time. Therefore, 2 children residing in the same household but sampled at different moments in a calendar year may present with different blood lead levels depending on the volume of traffic. To capture this risk, we collected daily data on piston engine aircraft departures and arrivals from the Federal Aviation Administration and monthly quantities of aviation gasoline sold at the airport. To give you an appreciation of the quantity of lead released, from 2011 to 2018, according to data provided to us by the county, 2.3 million gallons of lead formulated gasoline was sold at the airport. At 2 grams per gallon, that's over 10,000 pounds of lead consumed. Based on an EPA estimate that 95% of lead consumed is emitted, over this short 8-period window, about 5 metric tons of lead was emitted at Reid-Hillview. Importantly, these numbers do not include aircraft landing at the airport that fueled elsewhere. In addition to child proximity to lead emitting toxic release inventory facilities and residents in neighborhoods with higher risk of exposure to lead-based paint, we control for many other variables that are correlated with child blood lead levels. By combining all of these factors in a single statistical equation, we can estimate the independent statistical associations between our main indicators of avgas exposure risk, namely distance, near angle, and exposure to varying levels of traffic, we can make these linkages to child blood lead levels. In the presentation of our basic results, we begin with residential distance, then we'll move to residential near angle, and then measures of piston engine aircraft traffic and aviation gasoline sales. I just want to assure you before we get to the results on residential distance, that sampled children across these orbits of risk are statistically similar with respect to gender, residential near angle, age, piston engine aircraft traffic exposure, sample order, and year or timing of blood draw. On variables that we do in fact observe differences across children in these orbits, every single factor functions to inflate the blood lead levels of sampled children in those outer orbits. Therefore, whatever differences in estimated blood lead levels that may obtain between sampled children by residential distance, we may regard these differences as likely attenuated or conservative. Holding all other factors constant, we find that the blood lead levels of children in the nearest orbit are about 1/5 of a microgram higher than children in outer orbits. In percentage terms, sampled children most proximate to the airport present with blood lead levels that are about 10 to 11% higher than sampled children at a half mile to a mile and 1 to 1.5 miles respectively. Importantly, these results are highly stable to the incremental inclusion of control variables and are supported by analyses involving distance measured continuously. To provide context, this calculated difference of 1/5 of a microgram is approximately equal to 50% of the estimated increase in child blood lead levels at the height of the Flint water crisis observed over baseline levels in Flint. We know this to be true because we conducted and published an NIH-funded study analyzing over 21,000 samples in Genesee County before, during, and after the Flint water crisis. It is undoubtedly an imperfect comparison with respect to the nature of exposure. In one case, we have contaminated water entering a home. In the Reid-Hillview Airport case, we have atmospheric deposition of the toxicant. However, it is worth noting that the Flint water crisis from start to finish unfolded in less than a year and a half. By contrast, at Reid-Hillview, the release of lead into the lived environment is continuous, nonstop, a daily, unabated flow of an undeniably harmful toxicant. I remind you that we are talking about more than 1,000 pounds of lead released annually on nearby populations. Next, we share results pertaining to residential near angle. Recall, each child is assigned a cardinal direction to the airport. Because the winds prevail from the west-northwest, children east of Reid-Hillview should present with higher blood lead levels. Again, controlling for other factors and compatible with a hypothesis of avgas exposure risk. We find that children east of the airport present with blood lead levels that are significantly higher than all other sampled children. Residing east of Reid-Hillview is associated with a 0.4 microgram per deciliter increase in blood lead levels, equal to a 25% increase over other sampled children. This margin of difference is equal to the observed difference in sampled children before and during the Flint water crisis. Next, we share results pertaining to measured levels of P traffic, or piston engine aircraft traffic, sorry. This figure summarizes how blood lead levels change with an increase in traffic, accounting for all other factors. The upward sloping line here indicates the child blood lead levels increase as the quantity of piston engine aircraft traffic increases. This result is supported by the substitution of traffic for the quantity of aviation gasoline sold at the airport. Again, the characteristic upward sloping relationship. In going from the minimum to the maximum of child piston engine aircraft exposure, we find that child blood lead levels increase by about 0.3 micrograms per deciliter. This result obtains if we substitute traffic for the quantity of aviation gasoline sold. And this relationship is likely linear, as supported by analyses involving the division of traffic into low, medium, and high categories. In addition to these basic results, we perform several ancillary tests to extend and support the body of evidence to guard against hasty conclusion. Here are the many additional tests performed. I will focus on these three. If we have time, I could also share with you results from our relative school distance test. The first extension involves categorical measurement of blood lead levels to see if exposure risk to aviation gasoline increases the chance that a sampled child presents with blood lead levels in excess of 4.5 micrograms per deciliter, which is a very high reference value that the CDPH uses to allocate scarce resources toward the protection of the most vulnerable of children. Here we display two sets of results from this exercise. One set in light blue pertains to the probability or chance that a child presents with blood lead levels below 1.5 micrograms. And in navy, we have results pertaining to the probability or chance that a child presents with the blood lead level in excess of 4.5 micrograms. These probabilities are calculated by distance, near angle, and traffic. Fixing your eyes on the navy blue graphics, starting in the top right-hand corner, we find that a chance of a child at 1 to 1.5 miles, the outer orbit of risk, presenting with very high blood lead levels, is 22% lower than statistically similar children at a half mile from the airport. Children east of the airport are 2.37 times more likely to present with blood lead levels in excess of this reference value. Finally, we find that the risk of exceedance increases substantially if a child is exposed to maximum as opposed to minimum traffic. This is a restatement of what I just said. Next, we present results from a test that may be regarded as the most powerful of the tests performed. In this test, we ask a very simple question: whether the blood lead levels of children respond differently to fluctuations in traffic, depending on their proximity to the airport. Now, insofar as exposure to aviation gasoline is, in fact, an independent source of risk, then the blood lead levels of children most proximate to the airport should be more sensitive to changes in the quantity of traffic. I'm going to move a bit slower with this graphic here. On the horizontal axis, we have the quantity of traffic going from the observed minimum to the observed maximum. On the vertical axis, we have predicted blood lead levels. Two lines intersect the space, one corresponding to children within a half mile of the airport, and the other corresponding to children at a half mile to 1.5 miles. Allow me to use the language of medicine here. We can think of children in the nearest orbit as our treatment group, and children in the outer orbit as our control group. Now imagine that we turn a dial of traffic from low to high. Note how the blood lead levels of sampled children in our so-called treatment group, the inner orbit. Note how their blood lead levels rise steeply in response to the traffic. Also note how the blood lead levels of children in the outer orbit also increase, but more modestly. This statistical interaction is supported by the substitution of traffic for the quantity of gasoline sold. Overall, among sampled children at less than a half mile from the airport, an increase from the minimum to the maximum traffic is associated with an estimated 0.83 microgram increase in blood lead levels. This is substantially higher than what we observed at the height of the Flint water crisis. Children nearest to the airport are especially sensitive to changes in traffic. Resulting from various efforts to limit the spread of COVID-19, traffic at the airport declined measurably over the months of February to July in 2020. Traffic declined by about 34 to 44%, depending on the baseline used. Intriguingly, traffic recovered at the airport to pre-pandemic levels in August and December of 2020. These dynamics in aircraft operations at the airport present us with what economists call a natural experiment. Insofar as aviation gasoline exposure is a source of risk, then children sampled in this contraction moment should present with lower blood lead levels. This is precisely what we find. Children sampled in the contraction period presented with significantly lower blood lead levels than children not sampled in this contraction window. Given the reduction in traffic of 34 to 44%, the size of the estimated reduction is approximately equal in magnitude to what we observe in main results corresponding to our analysis of traffic. This is basically a restatement of what I just said. Now allow me to summarize. And I'm going to stay closely to the text here so that the summary of results is clear to all. Evidence from main analysis for a statistical link between aviation gasoline exposure risk and child blood lead levels include the following. Blood lead levels of sampled children increase significantly with proximity to the airport. Blood lead levels are significantly higher among children residing east and predominantly downwind of the airport, and increase in the downwind days from the date of blood draw. The blood lead levels of sampled children increase significantly with piston engine aircraft traffic at the airport and with monthly quantities of gasoline sold at the airport from the date of blood draw. Evidence for a statistical link between child blood lead levels and aviation gasoline exposure from extended analyses include the probability that blood lead levels exceed this very high reference value of 4.5 micrograms per deciliter increases with proximity to the airport, residing east of the airport, and with fluctuations in traffic. The blood lead levels of children proximate to the airport are significantly more responsive to changes in piston engine aircraft traffic and the quantity of lead formulated gasoline sold at the airport. The blood lead levels of sampled children in the piston engine contraction moment were substantially lower than children sampled outside this moment. Not shown this evening, but present in the report, children commuting toward the airport to attend school present with substantially higher blood lead levels than children commuting away from the airport to attend school. We estimate in the conclusion of the report that sizable economic benefits arise from a reduction in piston engine aircraft traffic. We conservatively estimate the cohort benefit at 11 to 25 million, a benefit that is given to all subsequent cohorts of children in perpetuity. On the need to limit lead exposure from aviation gasoline, the National Academies of Sciences, Engineering, and Medicine maintains, and I quote, because lead does not appear to exhibit a minimum concentration in blood below which there are no health effects, there is a compelling reason to reduce or eliminate aviation lead emissions. The ensemble of evidence compiled in this study supports the quote, compelling need to limit aviation lead emissions to safeguard the welfare and life chances of at-risk children and adults. Thank you.
Now we'd like to invite Dr. Lanphier to speak.
Thank you, Sylvia. First, I'd just like to add a little bit to the introduction, just to give you some perspective on why I was asked to share my perspective tonight and after this study was completed. I'm a physician and I'm a scientist, and I've studied how children are exposed to lead from various sources, from paint, the soil, and water and air over the past 25 years. I've also studied how lead damages children and adults. I've been fortunate to be involved in dozens of studies around the world. And I was asked to provide some perspective about this report to help the community understand the importance of it. As Sammy said, we know that lead is a poison. We've known that for over 2 centuries. Most of my research is really about to find out how much lead is too much. And as you can see with my title, what we found over the past 2 decades is that even a little lead is too much. I wanted to begin by giving you my impression of this report led by Dr. Zoran and Christopher Keyes and their team. First, by asking you a question. Imagine if you were asked to figure out whether these emissions from aircraft around Reid-Hillview Airport contributed to the lead circulating in blood of children in the neighborhoods. You would need to know how close they live to the airport, the household income, the amount of lead in their blood, and so much more. The age of their house, for example. You'd also need to be able to make sure that you can protect their privacy. On top of that, you need to find ways to prove or disprove that aircraft emissions were a source of children's exposure to this toxic metal. What they did was really quite remarkable. They merged a series of different databases like birth certificates, blood lead tests, government records of age of housing, income. And what they did very carefully, very thoroughly, is show how there really is no other conclusion but that children who live in these communities are exposed to lead from aviation gasoline, from aircraft traffic. They did a series of hypothesis testing to find out whether their hypothesis was right or wrong. And in the end, the results all pointed to the same conclusion. The Reid-Hillview Airport endangers the lives of people who live around the airport, especially children. Their report is one of the most thorough and conclusive reports I've read in my career. But they were also quite cautious, and I think underestimated the health impacts of lead exposure from aviation gasoline. And I'll come back to that in a minute. But first, I wanted to provide some perspective on the impact of lead and why we're so worried about lead toxicity, even at low levels of exposure. These are the 3 main ways we measure brain function in children, and we can measure the impact of lead on children. Cognition and reading, behaviors like ADHD, and even brain imaging, brain scans. And I'm not going to focus on brain imaging tonight, but we have seen that as children's blood lead levels increase, the volume, the size of their brain is diminished, especially in the prefrontal cortex. Now that area of the brain is smaller in children who have ADHD. And this study, a landmark study that was published in 1979 by Herb Needleman, showed exactly that. In over 2,000 children, they measured the amount of lead in their baby teeth. The children were asked to give the scientists their baby teeth, and they measured the amount of lead. And then the homeroom teachers rated the children's behaviors, whether they were hyperactive or impulsive, whether they were daydreamers, whether they were dependable in their schoolwork, whether they were organized. And across the board, as tooth lead levels increased, these behaviors became worse. Collectively, these behaviors represent what we now call ADHD. And in a national study, we found that children who had blood lead levels over 1.7 microgram per deciliter were 2 to 2.5 times more likely to have ADHD. Collectively, we estimated that about 1 in 5 children in the United States had ADHD as a result of lead exposure. There were certainly other reasons but lead was one of the most important ones we found. And as you saw from Dr. Zarin's report, we've seen this steep decrement. In this first study we did, it went right over my head, but we saw steep decrements in reading even beginning at the lowest measurable levels. It went right over my head and I didn't even notice it. But in our second study, we saw the same pattern. And what you can see here, just to repeat what Dr. Zarin said, is that at the beginning at the lowest measurable levels, we saw steep decrements in children's IQ scores. So that the first 10 microgram per deciliter increase in blood lead, we saw about a 6 to 7 IQ point decrement. From 10 to 20 microgram per deciliter, about a 2 to 2.5 IQ point decrement, and above 20 to 30, about 1 IQ point decrement. So what happens at the very lowest levels of exposure has a big impact on children's blood lead levels, especially when we think about it at the population level. And remarkably, in 2012, the Centers for Disease Control said there was no safe level of lead in blood. That's remarkable because for lead and other toxic chemicals, there is an assumption made that there are safe levels or thresholds, and that's been true for over 50 years. And so this really was a remarkable statement to say that for a toxic metal that we're all exposed to some extent, that there's no safe level was really quite astonishing. I want to share a quick animation that shows what happens as children's IQ scores drop by about 5 points. This is across a 6-year cohort of American children.
Typical distribution of IQ scores. Most of us have IQ scores that fall between 85 and 115 points. Only 2.5% of children have an IQ above 130, which is considered gifted. There are about 6 million children in this group. On the other end of the distribution, another 2.5% of children have an IQ below 70, which is considered challenged. The impact of exposure to a toxin like lead causes a 5-point drop in IQ. This shift results in a 57% increase in the number of children that are challenged, from 6 million to 9.4 million. There is a corresponding decrease in the number of children that are gifted, from 6 million to 2.4 million. Little shifts matter. The impact of exposure to another toxin, like flame retardants, results in a further increase in the number of children who are challenged, from 9.4 million to over 11 million. There is a further decrease in the number of gifted children.
So one of the big challenges for us in California and the rest of the United States is that children around Reid-Hillview Airport aren't only exposed to lead, they're exposed to high levels of air pollution in some cases, high levels of PBDEs. This is a type of flame retardant that's particularly high in Californian children, as well as OP pesticides and other toxic chemicals. And so we have to think about the cumulative impact.
Typical distribution.
Sorry about that. I also want to put in perspective something we call the prevention paradox. This is a little bit complex, but I think we can get this. Think about the current reference value that CDC uses is 5 microgram per deciliter. And about 500,000 children in the United States have a blood lead level in excess of 5 microgram per deciliter. On average, those children, after taking into account other factors like maternal intelligence, will lose about 6 IQ points here. And if we multiply 500,000 times those 6 IQ points, we'll see that those children lose about 3 million IQ points. Now we can come down to this next group. Children who have a blood lead between 2.1 microgram per deciliter and 5. Now there's a lot more of those children. On average, they lose about 1.5 IQ points. Not as much as these children, but because there's so many more children, right? 10 times more children, multiply that 5.7 times 1.6, you get 9 million IQ points lost. Collectively, if we only focus on children who have a blood lead level above 5, we would only protect or preserve 3 million out of the 23 million IQ points lost. That's why we have to focus on these low levels. Well, that's one reason we have to focus on these low levels of exposure. Here's another reason.
Lead toxicity doesn't only impair children, it affects people over their entire life. The ability to think and reason increases as we mature, peaks during young adulthood, and then begins to decline in our 60s. Children who have higher lead exposure never reach the same peak ability as children with lower exposure. At the other end of life, adults with higher lead exposure have accelerated decline in their mental abilities and may develop dementia sooner.
This is a good point to say that we're all exposed to lead. I was exposed to higher levels of lead than when I was a child, and children are today. But what this does is, by having some children, for example, those who live around Reid-Hillview Airport, who have higher levels of lead than other communities, they are put at a disadvantage, and they will have a greater likelihood of being impaired, just like this graph shows. Now, I said a few minutes ago that while I thought Dr. Zoran and his team's report was extraordinarily thorough and cautious, but I thought that they may have underestimated some of the impacts. And I want to share a couple ways that they underestimated the impact. They focused on children younger than 18 years of age, and yet by doing so, they underestimated the extent of ongoing exposure that these children experience. What I've done here is I've shown children under 18 years of age and the blood lead levels based upon the proximity to the airport. So this is the same as a graph that Dr. Zoran showed, but I've added on the blood lead levels of toddlers. And as you can see, the blood lead levels of toddlers are considerably higher than all children. And in fact, we're underestimating the difference because all children includes the toddlers. Why is that? Well, toddlers, for those of you who are parents or teachers, know that toddlers put a lot of things into their mouths. They crawl on the floor, and lots of dust and oftentimes soil or paint chips can get into their mouths. One of the ways we know that children are exposed to aviation gasoline is that it settles out onto the surfaces, and they're exposed through ingestion as well as inhalation. Think about it this way. Toddlers, if you thought about children as vacuum cleaners, toddlers are much better vacuum cleaners than, let's say, a 12-year-old group of children. Or you can think about it a different way. Let's try another analogy. Measuring blood lead is an indicator of a child's total body burden, but it doesn't give us the same measure that we'd get if we measure the amount of lead in bone. If you think about blood lead as, let's say, a monthly take-home check or a salary, a monthly salary, that gives you a ranking or an idea of how much wealth somebody has. But it's just an idea. You really need to look at their bank account and their house to find out how much wealth they really have accumulated over the years. Wealth in this case is like lead in bone. The majority of the lead that we absorb is stored in our bone. After menopause, for example, in women, their blood lead levels increase by 30% because they're wearing down their bones faster than they're building them up. Sammy showed you this slide as what he thought was the most persuasive, and I agree with him. And what you can see now, if you focus, this is on children younger than 18 years of age, or all children. As air traffic increases, you see this steep increase in blood lead for the children who live close to the airport, but really no change for the children who live further away in the blue line. But if you focus here on the maximum, that's about 2.5 microgram per deciliter. Now, what happens if we look at toddlers? We see the same pattern. As traffic increases, blood lead levels increase among children who live close to the airport. Not much of a change for children who live further away. But now look at the maximum is now almost, well, it's above 3, almost 3.2 microgram per deciliter. So by including all of these children who are younger than 18, they've underestimated the ongoing exposure. Now, that's not to say that older children who lived around the airport, say for 12 years, they do have a larger body burden of lead than a toddler, but most of it's been stored in their bone. And because they're not putting dust into their mouths, and because blood is a better indicator of recent exposure for toddlers, they've underestimated it. And so another way that they've underestimated it, not really underestimated it, but perhaps presented it in a way that may make it seem less substantial. One of the estimates that Sammy said is that if you live closer to the airport, your blood lead level increases by about 11%. But for some of these children, not only do they live closer to the airport, in some cases, they were exposed to maximum traffic, or maybe they lived east of the airport and were exposed to maximum traffic and lived close to the airport, or were in the lowest 10% of socioeconomic status. And what you can see is that not only does the mean blood lead level increase, but look at what happens here to the percent of children who exceed California's blood lead level of concern, 4.5 microgram per deciliter. It increases from 2.6 to 3.4 to 6.3 and 8.9. Now, this is with toddlers. I was on a working group. This is looking at 4.5 microgram per deciliter, and that's what's used currently. I was on a working group for the Centers for Disease Control, and we just voted unanimously to lower the blood lead reference value to 3.5 microgram per deciliter, and the CDC Lead Advisory Committee concurred. Well, what happens if we look at it? So instead of going from 2.6 to 8.9, what we see is now 5.7 up to almost 14% of kids exceed that new value of 3.5 microgram per deciliter. Now let's just look at that in context. So this is now looking at percent of children. This is all children greater than 4.5 microgram per deciliter, the toddlers in pumpkin color, and then the toddlers greater than 3.5. And you can see what's happening here. When you use children who are better indicators or better dosimeters of ongoing exposure, you can see that about 1 in 7 children exceed the level that's considered to be lead poisoning with this new cutoff of 3.5. As Sammy said, that's completely arbitrary. The blood lead levels of children today are still 10 to 100 times higher than our pre-industrial ancestors. They've also underestimated, as I've mentioned, because they relied on blood lead. Now, I'm not dismissing blood lead. All of my studies, well, most of my studies relied on blood lead concentrations. It is the optimal way to measure lead exposure in large population studies, large epidemiologic studies. But this study out of Yugoslavia by Gail Wasserman and her team showed that while both bone lead and blood lead shows you that same pattern, that is steep decrements in intellectual ability at the lowest levels of exposures, when you put both of those measures into a model, bone lead and blood lead, what you see is that bone lead is a much stronger predictor. It essentially knocks out blood lead. And so we're underestimating the impact by these studies that we've done looking at blood lead. There's also some other concerns that we need to be thoughtful about. In this slide, you can see that the typical size of lead and paint pigments is about 500 nanometers. And the typical size of lead particles in aircraft exhaust are about 4 nanometers embedded in larger particles of about 20 nanometers. But altogether, the key here is that lead particles in aircraft exhaust and in the past in motor vehicle exhaust are much smaller. Particles that are much smaller are more readily absorbed and get into the system and then into the brain and into the cardiovascular system to cause disease. So we need to be careful. We may be underestimating the impact or the toxicity of lead particles from aviation gasoline compared to paint. I wanted to briefly touch on another concern, and that is with coronary heart disease. Most of you know, of course, that sex, that is being male or female, has an impact. Being obese or smoking or having diabetes increases the risk for coronary heart disease, but toxic metals and air pollution do as well. And we completed a study now about in 2018, and I wanted to show you this because while most of the work and most of our discussion today has focused on children and the impact on brain development, what we found about coronary heart disease is also quite important because we don't see any threshold here either.
Lead is also a risk factor for coronary heart disease. That's when your heart is slowly or suddenly suffocated by an obstruction of the arteries feeding the heart. In a national study, we found that deaths increased sharply at blood levels below 50 parts per billion, the level considered safe. There was no threshold or safe level. If we let the narrowing of this coronary artery represent the risk of dying from heart disease, you can see that most of the narrowing occurs below 50 parts per billion. We found that lead accounts for about 185,000 deaths every year.
And that's in the United States. Now we use parts per billion. 50 parts per billion is equivalent to 5 microgram per deciliter. Now, since I've been involved as a reviewer of the report, I've heard crisis used in a couple different ways and inconsistent ways. And whenever that happens as a scientist, the first thing I like to do is to go back to the origin, go back to the basics and to look up the definition. Crisis, a time of intense difficulty, trouble, or danger. Or a time when difficult or important decisions must be made. And it seems to me this indeed is a crisis. This is a time where we've identified that children around Reid-Hillview Airport are exposed to a dangerous toxin, a toxin that will have lifelong implications. And it's a time when difficult and important decisions must be made. Thank you very much.
Good evening again, everybody. We are now going to respond to questions that have been submitted in writing. We have quite a number, over 110 submissions and growing. Some of them are statements, and we are going to collect those and make those available for our Board of Supervisors. We will now begin to present the questions and have Dr. Zaran respond to them. So I'm now going to introduce David Bruno, an analyst in the County Executive's Office, and he will read the questions. We also know that there may be questions submitted to us in Spanish or Vietnamese, and so we will try and flag those as well, get those translated and then submitted for consideration. So with that, Mr. Bruno.
Thank you. Our first question is, was there a control group of children who live further away from the airport to compare their lead exposure?
Thank you for the question. So we limited the geographic range of observation to children no more than 1.5 miles from the airport to guarantee that the children we compared to those residing near the airport were similar statistically on all observable characteristics to children further from the airport. And so you might think of children at 1 to 1.5 miles of the airport as functioning as our control group. Similarly, in our test involving the contraction of traffic at the airport, you might think of children sampled inside the contraction window as constituting a treatment group, and children sampled outside of the contraction window as representing our control group. Similarly, with respect to our test involving the movement of children from home to school, you might imagine the children commuting away from the airport to attend school as constituting something of a control group relative to children commuting toward the airport as constituting something of a treatment group. And so across all our tests, we're kind of sensitive to this question of differential exposure and thinking about that differential exposure as mimicking to the maximum extent possible the logic of a randomized controlled design.
Thank you. Next question. San Jose Airport is only 9 miles from Reid-Hillview. How is the proximity and large number of flights to and from San Jose Airport factored into the study?
It's a good question. It's not an airport that we studied exclusively. To our surprise, at least based on Federal Aviation Administration data, there is a non-trivial quantity of piston engine aircraft that presumably use lead formulated aviation gasoline. We didn't study the flight paths of these aircraft, and so that's not something I could provide an answer to.
Thank you. Next question. Your study takes samples from kids whose parents had reason to be concerned about lead, maybe old houses, bad pipes, etc., or were under state support. What part of your data set is from parents concerned with lead versus from kids who are under state support? Your paper does not mention.
That's an excellent question. It's not something that we're able to partition in the data provided to us by the CDPH. You are right that the children sampled and most likely to appear in the data possessed by the CDPH are children that are on programs like Medi-Cal. The question is whether those children are more or less likely to reside near or far from the airport, are more or less likely to be sampled in periods of high versus low traffic, are more or less likely to reside east of the airport. Now, it's not possible to see exactly, but on all of the observable characteristics that we can observe, the children are statistically similar with respect to those characteristics. And presupposing that what we can't observe is proportional to what we can observe, it's unlikely that that bias operates through our tests in ways that cause an inflation of the blood lead levels of children that are near versus those children that are far.
Next question, and there are several questions related to alternatives pathways. First, I'll take one related to other airports. As the presenter is talking about lead levels in children located downwind of the airport, Did you account for the lead carried by wind from other airports like San Jose, Moffett Field, Palo Alto, San Carlos, San Francisco, Hayward, or Oakland?
No, we did not explicitly, no.
And on a similar note, a question was received relating to the study area. Why was it limited to 1.5 mile or 1.5 mile radius and not further?
Again, similar to a question already asked, the aim was to observe like children. Extending beyond 1.5 miles introduces children of different socioeconomic status, introduces children that may have other sources of lead present in their environment that vary from children that are proximate to the airport. To the maximum extent possible, we were aiming to compare like children. Also, the evidence indicates, at least with respect to the EPA report, with respect to what was discovered by Miranda et al., what was discovered by my team on the state of Michigan, the risk appears to dissipate substantially beyond 2.5 kilometers from an airport. So it did make theoretical sense to extend the analysis beyond 1.5 miles.
Are any peer review issues still being explored? What are items that peer reviewers were concerned about with the study?
Thank you. One of our first reviewers expressed concern about the lack of control for seasonality. So this was an adjustment that we made to our models. Another reviewer asked for, it's sort of a technical request, to account for children that are repeatedly sampled by adjusting our standard errors in the model. So clustering our errors by repeat sample, both of which we addressed. Those were the, I think, two technical, the technical feedback that we received. I think both reviewers were pleased with the rigor and the conscientiousness of the report. Since the release of the report, we've had many questions posed to us, and I could maybe share my screen again to sort of illustrate some of the reviewer-like questions that we've received. Can you all see my screen?
Yes, we can.
Let me see if I can open this for you. So one of the questions that we received pertained to the Bay Area Air Quality Management District data. These data were provided to us by the county on February 2021. And these data covered the period of February 2012 to 2018, measuring atmospheric readings at the airport at a 6-day interval. We merged these data with our inventory of blood lead samples, children under 18 years of age, residing within that 1.5 mile distance to the airport. And given the time abbreviated nature of the air quality data, only 11,000 of the 17,241 blood lead samples used in our analysis could be assigned an atmospheric lead concentration coincident with the timing of blood draw. And so this resulted in a loss of about 1/3 of all observation. And this is what warranted caution in the use of these data. Nonetheless, we have since then analyzed that data estimating this parameter corresponding to the concentration of lead in the atmosphere at the airport. And after performing this analysis, we arrive at very similar results. Along the horizontal axis, we have atmospheric lead measured in micrograms per cubic meter. And on the vertical axis, we have predicted blood lead level. And going from minimum to maximum atmospheric concentration at the airport, blood lead levels on average rise from 1.79 to 2.1 micrograms per deciliter, a difference of 0.3 micrograms per deciliter. Almost on par exactly with what we observe in our use of piston engine aircraft traffic. With respect to other sources, people have asked questions about water lead exposure. We managed to find data from the Division of Drinking Water, an entity of the California Water Board. And this entity, in collaboration with the California Department of Education, has tested lead in drinking water at all public schools, K through 12 statewide. We identified all public schools within 1.5 miles of the airport, inventoried in the DDW data. This is a table showing the complete inventory of water lead samples at all schools within 1.5 miles of the airport. Not one sample taken from these schools is in excess of action levels. In fact, not one sample taken from these schools is above the limit of test detection. Others have asked us to look at distance to the historic San Jose Speedway. We find this to be a very intriguing question, and we have Michael McDonald to thank for alerting us to the history of San Jose Speedway and forwarding this intriguing hypothesis. We managed to find the lat-long coordinates of the historic land use. And as we did for proximity to the airport, we estimated the effective distance to this historic land use in both continuous and categorical terms. And across all statistical models rendered, this is a portrait, by the way, of the historic land use relative to the airport. Across all statistical models, we find no effect with respect to proximity to this historic land use. That is, proximity to the old San Jose Speedway is statistically independent of blood lead levels. As Dr. Lamphere noted, we've been asked to restrict to toddlers, and we've performed various analyses in this direction, trying our best to corroborate the intuition that maybe younger segments of the population are particularly at risk. We've been asked to consider the gains from limiting exposure. And then finally, we've been asked about the point location decision and all the analyses that we performed subsequent to that ask, shifting that point location down the runway, recomputing all of our analysis, demonstrating again that proximity to the airport is hazardous to children, that the blood lead levels of the children fluctuate with observed traffic, and that the children east of the airport are more at risk than children west of the airport. Now, there are other things that people, I'm sure, can imagine that implicate the blood lead levels of children. And I want to remind readers of a particular section that we had in the report. I'm going to read from this section. It's technical sounding, but I will try to explain it to you by way of analogy. We write, importantly, gamma sub j is the neighborhood or census block fixed effect. Inclusion of gamma accounts for non-time varying unobservable factors which may influence blood lead levels that are common to sampled children within a given neighborhood, but varying across neighborhoods. These fixed effects absorb omitted variables by estimating a distinct mean blood level or intercept for each neighborhood. Now, I'll try to translate that in English. Let's imagine that you've been asked by the California Department of Education to estimate the effect of a school program like free and subsidized lunch on test performance among fourth graders. Now, let's also assume that you have other information about the child, right? The sex of the child, the age of the child, historic performance on various standardized tests. Let's also assume that you have an intuition that other things matter in test performance. You have some sense that the classroom itself matters, but you don't have good data available to you to quantify this classroom effect. I suppose maybe you could observe the teacher-student ratio, but you have this sense that the composition of the classroom implicates the test performance of children. Well, a common econometric strategy is to have an indicator for all classrooms present in a school and across schools within a school district, coarsely capturing all things present in the classroom that one cannot observe. The same thing obtains in our study. We can't see everything that is happening inside a neighborhood, but we can have an indicator for every single neighborhood in and around Reid-Hillview. And we can estimate an effect springing from that neighborhood, independent of all other effects. And so our estimates on the effect of distance or proximity to the airport, living east of the airport, fluctuations in traffic are expunged of these omitted variables present in these neighborhoods.
And I'm scanning to see if there are others.
Okay, next question. Have similar studies been completed at other airports, and how do their results compare?
Thank you for that question. The Miranda team in 2011 published their study in Environmental Health Perspectives. The study looked at, I believe, 66 airports across 6 counties. They looked at 125,000 lead records. Like the Reid-Hillview study, they found that blood lead levels increased significantly in proximity to the airport, with children at less than 500 meters and 1 kilometer from the airport at greatest risk of elevated blood lead levels. The second study, and these are the only 2 studies that I'm aware of, is a study that I performed with colleagues while doing a fellowship at Columbia University, financed by the Robert Wood Johnson Foundation. We examined child proximity across 448 airports. We examined the effect of prevailing winds, the direction of those prevailing winds. We examined the effect of fluctuations in piston engine aircraft traffic at a subset of 28 airports, with perhaps the most compelling test performed, looking at this striking moment when, after the tragic events of 9/11, for fear that a similar event might occur, there was a subsidence in traffic, and children proximate to airports, sampled in this moment of a reduction in traffic caused by this tragedy, witnessed a substantial reduction in their blood lead levels. And so to us, this was as if an experiment was performed where we turn down the deposition dial. And when we do that, child blood lead levels retreat. By the way, the results with respect to the distance coefficient are similar in size and magnitude to what we observe in the Reid-Hillview study.
Thank you. How do percentages around Reid-Hillview compare to blood lead levels nationally? What percentage of children across the country have these blood lead levels that we are seeing at Reid-Hillview? The questioner goes on to describe the CDC limit of 4.5 micrograms per deciliter. Does this mean Reid-Hillview is the same as if we were to take blood lead levels across? You're on mute.
Those are two excellent questions. So I have not looked at the random probability samples conducted by the CDC to look at the distribution of lead nationwide. The average, the last I looked, was sub 1 nationwide. The 97th percentile in the data today, as Dr. Lanphier noted, is around 3.5 micrograms per deciliter, which is what we observe among toddlers proximate to the airport under periods of intense traffic. Now, the reference value referred to of 4.5 micrograms per deciliter is not a threshold of concern. It is a statistical notion corresponding to children in the 97.5 percentile in the distribution of all children. The CDC has concluded, and this is a conclusion I must agree with, that there is no safe level of lead in a child's bloodstream. Dr. Lanphier, you may have a comment or two in this direction with respect to the statistical reference value.
Yeah, I mean, if we look, Sammy, at the data that you provided for me, about almost 6% of kids, toddlers, who lived within a half a mile of Reid-Hillview Airport, almost 6% of kids had a blood lead in excess of 3.5. So that is somewhat higher than the national average. And then, of course, as you add some of the other factors, traffic, larger traffic, higher traffic, living east of the airport, all of those will add up, and you see an increase in the percent of kids who exceed 3.5. So certainly some groups of children around Reid-Hillview Airport have blood lead levels 2 to 3 times higher than what we see nationally, but that's looking at specific groups with specific characteristics or risk factors.
Thank you. Our next question it has to do with alternative pathways again. Did the study take into consideration other factors in households such as lead paint interiors?
Yes. So we could not observe the age of the home that the child was residing in at the time of blood draw. But what we could do was proxy for that risk by looking at the age of the housing stock. Let me share with you my screen again, and I can go to the report itself. Have you look at a picture that sort of motivated our decision making. Can you see, David?
Yes, we can.
Okay, great. So here we have lead usage in tons times 1,000 from 1910 to 1990. And we're graphing here the two major sources of lead over the 20th century. Lead in automotive gasoline and lead in paint. So let's fix our eyes on this line right here in navy blue. You could see that lead in paint constituted the major source of lead usage from 1910 to 1930. The use of lead in paint subsides. So by the time we get to 1960, it's 90% off peak usage in 1920. So what we did is we said, okay, well, maybe we can look at the fraction of the housing stock in a neighborhood built in this period before 1960. Now, lead in paint wasn't officially phased out till 1978, but the majority of homes built from 1960 forward did not have leaded paint. So all of our statistical models control for the percentage of the housing stock in a neighborhood built prior to 1960 to account explicitly for this other source. The second source that we focused on, given the availability of data, something that we could measure explicitly, is the complete inventory of lead emitting toxic release inventory facilities observed over the period of 2011 to 2020. We counted every facility operating in every year involving a submission of an emissions report to the TRI system. So we found where all of these facilities are located. And up here, imagine this is just to illustrate the measurement logic. We took every child and we drew this 2-mile radius orbit, and we counted every one of these facilities proximate to that child as an additional source of risk that may account for the blood lead levels of children. Again, I remind you to the use of fixed effects in the model that function to absorb all other unobserved factors that are present within a neighborhood and different across neighborhoods.
The next question relates to the blood lead level versus IQ graph. The graph begins at about 1 to 2 micrograms per deciliter. The graph looks nearly vertical at that point. If you extrapolate to the left, does this mean that someone with 0 BLL would have an infinite IQ? Or would the average person with no lead exposure have the average IQ of 100?
Yeah, of course not.
The report discusses reducing piston engine aircraft traffic as a way to control the problem, but would it be more accurate to say that reducing lead emissions is the actual problem and that reducing piston engine aircraft traffic is only one way of accomplishing that?
That's an excellent question. In our simulation exercise at the end of the report, we're imagining the reduction in traffic, in part because, in fact, we do simulate also reduction in the quantity of lead formulated aviation gasoline sold at the airport. And so under both scenarios, we do witness or expect to witness a substantial reduction in the blood lead levels of children. And in that exercise, we connect the blood lead levels of children to expected gains in IQ. And then we continue this syllogism by connecting IQ to expected earnings over the life course based on studies that have made that linkage to try to give us a conservative sense of the quantitative value associated with reducing lead emissions at the airport, whether it comes from a reduction in piston engine aircraft traffic or a reduction in the use of leaded aviation gasoline.
How long does lead stay on the surface or in soil after it is deposited?
I don't have an answer to that question. I have written many papers on the relationship of the accumulation of lead in surface soil and child blood lead levels. It's an underappreciated pathway, I think, in the environmental health and epidemiological communities. The work by Dr. Howard Milkey at Tulane University is where I would look for that answer, but it can persist for many years after it's deposited. With respect to surfaces, the only work that I've done on surfaces, involved child playgrounds and timed play at a playground and wiping the hands of persons who played at a playground for about 30 minutes and observing the metal content on their hands. And in the paper, we tried to estimate the number of times one would have to wash the playground to limit exposure, and it came out to something crazy, like 3 times a day to actually get it to a safe level. But this was a playground that was proximate to a mine in Australia. So I'm not certain of how long lead remains on surfaces. Bruce, do you have anything in this direction?
Well, if we're thinking of soil, it will tend to stay there. It can be stirred up again. But if you look, for example, at older houses and you look at the soil taken from around the foundation of those, the perimeter of the foundation of those older houses, they will consistently have higher levels than newer houses. So much of it will stay there. It's an element, so it's not going to be changed or altered. But you can get some stirred up again. If there's demolition, for example, or excavation, it can get stirred up. If it's a dusty, dry season, you can get some stirred up. But for the most part, a lot of it will stay, just like a lot of it stays in our bones once we've been exposed.
Thank you. Next question. It is confusing to look at predicted BLL versus measured BLL between the two presentations. Can you please clarify?
So you use the language of predicted blood lead levels because you're estimating this equation based on observed blood lead levels. And you are calculating the independent effect of each factor in determining the observed blood lead level. And so in those graphics that we showed, we set all other factors that could possibly implicate the outcome to the average. And then we simply turn on a switch of whether or not the child is proximate to the airport, whether the child is east of the airport, and turn a dial over the observed range of piston engine aircraft traffic to get the conditional mean value of blood lead levels. So let me try to explain it this way. Imagine, you're looking at 2 populations of children. And we know that boys have substantially higher blood lead levels than girls. Now let's suppose that the blood lead, that one group had 70% boys and the other group had 40% boys. If we were to simply calculate an average over those two groups, it might simply reflect compositional differences, with one group having more boys than the other group. Now, what you want to do is, if you're interested in another factor lurking in the two groups, you want to condition the mean estimate on the sex of the child. And that's precisely what those graphics do.
Thank you. Do we have any studies on the behavioral effects of lead exposure on adults and speculation on the harm occurring in the nearby adult population?
I think that's a question that Dr. Lamphere can answer. I could also share with work that I've done on motor neuron disease mortality and exposure to lead formulated petrol in Australia. But Dr. Lamphere?
Yeah, I'm not aware of any studies that specifically looked at aviation fuel as an exposure, but what we know from using blood lead measures is that lead exposure, even at low blood lead levels, is an established risk factor for hypertension, death from coronary heart disease, essential tremor, renal failure in adults. There's suspected associations of lead exposure and ALS, or Lou Gehrig's disease, of dementia. Those are some of the more well-studied but not definitive, the latter ones. In our study now looking at coronary heart disease deaths, I mentioned it very briefly, we estimated that lead was the leading risk factor for death from coronary heart disease in the United States, after accounting for smoking, obesity, diabetes, all of those other factors. We also saw, and this was one of the natural experiments that Sammy mentioned that can be done, during the 1980s, there was a precipitous decline in hypertension in American adults. In the early parts of the 1980s, 1 in 3 adults had hypertension. By the end of that decade, it was 1 in 5. That's a huge drop, and it couldn't be explained by smoking, treatment for hypertension, obesity, which indeed was on the rise, or how it was measured using blood pressure cuffs. What did happen, though, during that decade was lead was taken out of gasoline, and blood lead levels plummeted from 13 microgram per deciliter in the late 1970s down to 3 microgram per deciliter. So we have good evidence. There's also a randomized controlled trial where they gave a chelator to research participants who had experienced a cardiovascular event. Following chelation, compared to the placebo group, they saw an 18% reduction in subsequent cardiac events. Among research participants with diabetes, they saw a 34%. Also, this was out of Taiwan, they saw, using a chelator in a randomized controlled trial, a 50% reduction in progression to chronic renal failure. So we've got good evidence, and indeed the EPA concluded that lead is a causal risk factor for coronary heart disease. The National Toxicology Program of NIH concluded that lead was a risk factor for hypertension, tremor, renal failure in adults, and in children, ADHD, conduct disorder type problems, and IQ deficits. So those are established risk factors in adults and children.
I could also share some of the work that Dr. Keyes performed in his dissertation that speaks to the long reach of early childhood exposure. Again, allow me to share the screen. So this is one of the natural experiments performed. So this is a graphic showing the grams, average grams per gallon of leaded automotive gas sold across the states, moving in time. The darker the cell, the higher the concentration, the grams per gallon. Christopher leverages the differential phase out of automotive gasoline across states and in time to link childhood lead exposure to performance on standardized tests in early adulthood. Christopher also examined the extent to which this early life exposure that's being quasi-randomly determined across states in time, depending on the speed or pace of phase out. He shows that there are changes in personality traits corresponding to a willingness to engage in risky behaviors. More recently, I've seen a study leveraging this kind of statistical procedure to show changes in personality in adulthood. We find in a study from New Zealand, adults exposed to high quantities of lead in early childhood not only have lower measured intelligence in adulthood, but lower occupational status, with the differences between lead exposed and non-exposed adults appearing to amplify over the career course. Not only is it cumulative, but the effects appear to worsen in time.
Dr. Zaran mentioned 1,000 pounds of lead emitted per year from Reid-Hillview Airport. How did you come to this number? You're on mute, Dr. Zaran.
Allow me to unmute and allow me to share my screen again because I have the data available to us. So the data here are moving monthly. And this is the quantity of aviation gasoline sold at Reid-Hillview in gallons from January 2011 all the way to December 2018. These numbers come to us from the fuel flowage data provided to us by the county. Because you have about 2.12 grams of lead per gallon of lead formulated aviation gasoline sold, one can easily derive grams by multiplying that quantity by 2.12 grams. You can convert grams to pounds, and then you could sum pounds emitted over this period to get to your number of 10,000. Assuming that 95% of that consumption is released or emitted, you get to this number of 10,268 pounds emitted. Given that this is an 8-year period that we're observing, taking this number and dividing by 8, you get to this number of 1,200 pounds emitted annually.
Our next question is relating to a wind direction. The wind would predict that children to the south should also have elevated lead levels, yet the data does not support this.
That's a good question. It's the manner in which we set the wedge setting. So let's see if I can go to the report, or actually we go to the presentation so I can share with you how this works. Can you see? Okay.
Yes, we can.
Okay, excellent. So the winds are in fact coming from the northwest, as the questioner noted. And so you would expect children in the south, but it's not quite the south. It's children in this portion of our eastern wedge, the southeast portion, that are subsumed under this larger category of children that present with systematically higher blood lead levels.
Is the county studying lead levels at San Martin Airport and its surrounding community too?
So we in fact set out to do so. As you may know, the count of persons residing around San Martin Airport substantially smaller than the size of the population around Reid-Hillview. And because the population size is so low, few blood lead samples appeared in the data available to us from the California Department of Public Health. Only 68 blood lead samples over a 10-year period were available to us at San Martin Airport, prohibiting credible statistical analysis. I mean, I could give you an average over that 10-year period, but it would basically be meaningless, but it is substantially lower. I think 1.4 was the calculated mean at San Martin relative to the substantially higher numbers that we're seeing around Reid-Hillview.
Our next question is probably for Dr. Lanfear. Why do blood lead levels go down from toddlers to teens? Does the lead leave the child over time as they age? How does this happen?
Yeah, the blood lead levels go down because the lead in the blood is being taken up by the bone. As the bones grow, as the bones remodel, it's being stored in the bone. The body thinks it's calcium. It can also mimic other metals like iron, but it predominantly thinks it's calcium. And so it's stored in our bones and in our bony tissues like teeth. And so we don't get rid of it easily. It stays with us. And so, as I mentioned, an example, if you look at women as they go through menopause, they lose the ability to build up the bones. And so they're losing more bone than they're building up. We're all constantly rebuilding our bones. It's a constant process. But after menopause, you break it down more than you build it up. And you can see blood lead levels go up by 30%, releasing a lot of that lead that's stored in the bone. You can also see lead released from the bone when you fracture a bone, particularly a long bone. There's a increase in lead that circulates because it's being released as that bone fracture is remodeling. So most of it is retained. It's not released. The challenge is measuring it. So if we looked at, it's hard to measure bone lead in a 2-year-old, very difficult. But if we could measure it in a 2-year-old, the amount of lead in the bone would be much lower than an 18-year-old. So you have to think about the 18-year-old has been exposed. Let's say all other things were held equal. Both children grew up on the east side within half a mile of the airport. If we measured the amount of lead in the bone of the 18-year-old, it would be considerably higher than the amount of lead in the bone of the 2-year-old. But because the 2-year-old is still crawling around on the ground, still putting lots of food in their mouths. And because pound for pound, 2-year-olds ingest more food and dust, breathe more than older children and adults, and drink more. We typically see that toddlers are better indicators of contamination in their environment, whether it's lead or pesticides or tobacco. 2-year-olds tend to have a larger body burden when we measure the toxic chemicals in their blood or pesticides in their urine.
Thank you. With respect to the study, how many children were involved? When were the children tested, and how was the data compiled?
So the data are compiled by a platform called Web Collect under the control of the California Department of Public Health. Their labs send records to the state of California, where a complete inventory is kept of all blood lead tests conducted in the state of California. Our estimate is around 7 to 9 million records available in the database. For not all children, but many, because there's incomplete information on each record, you have an indication of the date of draw and the date of birth of the child. And so between those two dates, you could discern the age of the child. And because you're given a residential address, you can geocode that address to find the child's true location on Earth at the point of draw. And so over this observation period, there were 17,000 plus records available to us for analysis, satisfying that inclusion criteria of being within a 1.5 miles of the airport, sampled within the last 10 years, and having an observed blood lead level, and being 18 years of age and under. So it's the complete inventory.
Our next question. Given the history of lead use in the Bay Area, in shipbuilding, etc., how can the presenters feel so confidently about this one issue as driving the data observed? i.e., how can they feel confidently that they can control for the many sources in the environment?
Again, excellent question. I mean, the study was not meant to be a complete analysis of all sources of lead and a partitioning of the outcome to all of those sources. That was not the purpose of the study. The purpose of the study was to isolate to the maximum extent possible the independent effects of lead. So let's assume that the historic use of lead in shipping is an important factor for determining the quantity of lead in a person's bloodstream. The challenge, I think, would be to explain how that risk factor behaves differently across children of varying distance to the airport. You would have to explain how that risk factor behaves, that historic factor behaves differently over observed traffic at the airport. You'd have to explain how that factor implicates differently the blood lead levels of children west and east of the airport. So you would need an alternative explanation that could account for all of this evidence pointing into the direction of an independent effect emanating from the airport.
And Dr. Lamphere, teeth are formed in the embryological phase. How is lead measured in a child's teeth? And how can you confirm that a child's blood lead level is not in fact from the mother and not directly related to Reid-Hillview and lead-based piston.
Well, we don't have any tooth studies that I know of specifically from this airport. We can do that, but we can say that we can use teeth as what we call biomarkers of lead exposure, because we have studies where we've looked at, where me and my colleagues have looked at exposures in the environment to blood and seen how that correlates with what's in their shed baby teeth. There's also been studies that have looked at that in laboratory rats where you can control the amount of exposure they have. You're actually controlling it, and then you look at whether their teeth are picking up on that. So those are the main ways. And again, while those types of studies, the tooth lead studies, weren't done at Reid-Hillview Airport, we can say that given these other studies, there's some relevance to what I was pointing out, and that is, if we did have these cumulative measures of lead, like lead in teeth, like lead in bone, we would see most likely a stronger relationship with proximity to the airport, with the wind direction, and we would estimate to a greater extent more exposure. But because we're using blood lead, we're getting more of a snapshot. So that really has more to do, though, with the interpretation, how we take this study and we make inferences about the long-term impacts.
Our next question, did you have something further to say?
Well, I just wanted to add on to what Sammy said. What convinced me was the consistency of their findings after taking into account other factors. That is, they showed that there were no meaningful differences between those children who live closer to the airport and further away in terms of a number of other factors that could be related to lead exposure. They showed with the contraction that blood lead levels fell down. They showed that proximity. And it's not just this one study, although this study was convincing. It's this study in relationship to the previous two studies and what we know about air lead level and what we know about children's exposures, right? So when I first read Sammy's study, the first thing I said was, we should look at toddlers. Toddlers are better indicators of lead contaminated environments. And that's exactly what we found. So this study does exactly what we would expect it to do based on the other two aviation gas studies and on all the epidemiology that's been done over the past 2 to 3 decades.
Good evening, everyone. Sylvia Gallegos again. I think what we're going to do, we said we're going to end at 9 o'clock, but I would like to give our researchers a 5-minute break. I see that Dr. Zaran may have stepped away, so we will be back in 5 minutes, which is, by my clock, 8:25. Thank you. We'll be right back. Good evening again. We are coming back online after our 5-minute break. I see that Dr. Zaran is back. And so with that, I'm going to turn it over to Mr. Bruno to ask more questions. Thank you.
Thank you. Our first question after the break is, how do you explain how that the Bay Area Air Quality Management District never found significant lead levels of concern and opted to discontinue monitoring for lead at Reid-Hillview Airport after concluding that lead levels in the vicinity of the airport were insignificant?
Thank you for the question. Allow me to share my screen. So again, as I noted earlier, we did in fact study the relationship between atmospheric lead at the airport and blood lead levels in children, finding this upward sloping relationship compatible in magnitude, the relationship between blood lead levels, the quantity of aviation gasoline sold, and measured piston engine aircraft traffic. Now, with respect to the relationship between, is this relationship plausible? I point you to a study performed by a group of scientists from the Environmental Protection Agency and various professors at various universities, large team of people involved that are estimating this relationship. It's a pretty remarkable study because they gained access to the geographic location of children in this random probability sample that's performed by the CDC. They identify this relationship, but more than that, they look at all studies that looked at this relationship and amassed these studies to identify the relationship between atmospheric PB and blood lead levels in children. And I want you to fix your eyes on the horizontal axis. Note the range that we're looking at of 0 to 0.1 micrograms per cubic meter. And across all of these studies, we see this characteristic nonlinear relationship where blood lead levels decline substantially at lower atmospheric measures of lead. The results from our analysis are consistent in the expectation of the reduction in blood lead levels when one is going over the range of observed values at this monitor over this period of time.
If I could just add to that, I was a member of the National Ambient Air Quality Standard Committee for lead in 2008, and it was clear then, and it's clear still today, that the decision to take down the national air monitors for lead was premature. We still need them. We need more of them. And in their absence, what Sammy did here was to use children as monitors of lead contamination. And what he just showed you in that study was that they're pretty good monitors, unfortunately. But we need to put those air monitors for lead back up.
Next question. Where in the literature can I find information on the relationship between airborne lead levels and blood lead levels?
That's what I just covered, in fact. So I would highly recommend this study right here, published in Environmental Health Perspectives, which is arguably the best environmental health journal in the world. This study was, I believe, published in 2014. And again, what I like about this study is, in addition to gaining access to the geographic location of children in this random probability sample, they looked at numerous other studies that have estimated this relationship. So if you just mine the bibliography of this study, you can identify all of these studies that have looked at this relationship, including a study that I performed with some colleagues in Michigan in 2013 that appears in the journal Environmental Science and Technology. So again, the influence of declining air lead levels on blood lead, air lead slope factors in children. It's kind of technical, but you could see these dose response relationships pretty clearly.
Thank you. If 1,200 pounds of lead is released from avgas purchased at Reid-Hillview each year, How much of that lead is released within 1.5 miles of Reid-Hillview?
That's a good question. I don't have the answer to that question. Absent the ability to observe the flight behavior of each plane, it's not it's not a question that one can answer.
To be clear, the planes at San Jose Airport use the same or different type of fuel as the planes at Reid-Hillview.
One more time, please repeat, David.
Let me rephrase it. Do the planes at San Jose International Airport use the same or a different type of fuel as those at Reid-Hillview?
A different type of fuel. Not lead formulated. The vast majority of flights at San Jose Airport do not involve piston engine aircraft that use lead formulated gasoline, unlike Reid-Hillview.
In the current data set, was there a signal due to COVID air travel curtailment?
Yeah, that's in fact what motivated the contraction experiment. In observing the general aviation traffic and the piston engine aircraft traffic specific traffic, we observed a reduction of 34 to 44% in total operations from late February to August of 2020. So you could think of this as a moment where we have this external force that is reducing the quantity of traffic. And precisely in that moment, we observe a subsidence in the blood lead levels of children.
Thank you. This question is, I think that this is a general question relating to lead and not specifically about Reid-Hillview. Have there been studies on the impact of lead exposure on pregnant mothers and the impact on a baby in utero?
That's an excellent question. Few studies that we're aware of, but I point you to Christopher Key's dissertation, and this is a question that we pursue, in fact, leveraging that natural experiment I described to you in the differential phase out of leaded gasoline in cars across states and in time. And we looked at something on the order of 6 million births in the United States over this period, finding that as you increased the blood lead levels of the mother during pregnancy, it substantially increased the likelihood the child would be born premature before 37 weeks of length in the gestation, that there was an increase in the risk that the child would be born low birth weight at 2,500 grams or less, an increase in the risk that the child would be born very low birth weight at 1,500 grams or less. We also observed a reduction in APGAR scores used to assess the health of the child at the point of birth. And so across many, many tests, measuring the birth weight in grams, the risk of prematurity, the gestation length itself, the APGAR scores, we find that as you increased the quantity of lead present in the bloodstream of the mother, it substantially weakened the life outcomes of the child at the point of birth.
And just to add on to that, David, there's also very consistent evidence, and I think Sammy's been involved in some of these studies as well as I, showing that women with higher blood lead levels also are at increased risk for preeclampsia. It's a hypertension of pregnancy, which can lead to severe outcomes as well.
Thank you, Bruce, for that reminder. In fact, it was a study that I performed with Dr. Howard Milkey, where Howard had done this high density soil survey work in the city of New Orleans before the inundation of the city with the failure of the dams and levees that led to a flooding, I think, of 80% of the city. And he had the good wisdom to go out and resample the soils of the city. And what he discovered is that the sort of spatial variation that obtained prior to the flooding had been reduced substantially, with neighborhoods looking more alike in terms of the soil lead accumulation after the flooding as compared to before. And so you ended up having some places that witnessed an increase in the concentration of soils, and some places that witnessed a substantial decrease in the quantity of lead in soils. And we leveraged this exogenous movement in soil lead accumulation as a natural experiment in lead exposure for pregnant women. And what we found is that those mothers residing in areas that witnessed a substantial increase in soil lead accumulation had a corresponding increase in the risk of preeclampsia and hypertensive disorders during pregnancy. And in those places where we witnessed a substantial reduction, again, resulting from the inundation of the city, we observed a substantial retreat or reduction in the risk of preeclampsia. So we were pretty convinced by the natural experimental quality of the study in making this explicit link.
Thank you. Our next question is related. Is there a correlation between lead exposure in pregnant women and children born with special needs?
I don't have an answer to that question, but we do know that low birth weight is linked to many deleterious outcomes. And so we can confidently say that maternal exposure to lead in pregnancy increases the risk that the child is born low birth weight, depresses the total weight of the child. The economic costs associated with a low birth weight outcome is tenfold that of a normal weight birth from birth to age 18. And so economists and epidemiologists often use low birth weight as a variable to forecast depressed life chances over the life course. So I wouldn't be surprised to observe such a link if a study was rendered.
If this question relates to nonlinear dose response, am I understanding this correctly? Dangers to children increase with a decrease in blood lead levels. You're on mute, Dr. Duran.
I'm going to share my screen again, and I'll kind of walk through the logic of that to give you a sense of what is meant by nonlinear dose response. I know it's a technical language, but so what we mean by nonlinear dose response is, let's imagine I have two children, one child with a blood lead level of 10 micrograms per deciliter. Let's imagine I have another child that has 1 microgram per deciliter. Now, I want you to imagine that we expose these two children to a source of lead that increases their blood lead levels by 1 microgram per deciliter. So if we go from here at 1 to 2, you have to imagine as we go up to the vertical axis, we can see that the difference, the amount of the reduction in child IQ would be more substantial with the addition of 1 microgram at low levels vis-a-vis the addition of 1 microgram at substantially higher blood lead levels. You could see that the decrement in IQ would be substantially smaller out here than it would in here. Does that make sense? Bruce, do you have something to add? I mean, you've devoted your life to this. Or
Yeah.
yeah.
I think you captured it nicely. The other piece of information that I think will help here is that if you take that child out at 5 microgram per deciliter, they also have already experienced that subsequent decrements in IQ. So having a blood level of 10 or 20 is absolutely worse than having a blood level of 1 or 5. But increasing your blood lead from 1 to 2 is associated with a steeper decrement, greater decrement in IQ than going from 14 to 15.
That's
It's always better to,
yeah. And Bruce, I think the other logic of this that I find compelling personally, right, is that the gains that one can make in that last mile of reduction in the blood lead levels of children delivers substantially higher benefit than the reduction in blood lead levels way out here, right? So imagine you accomplish something of a reduction. So the logic of going from 30 to 29 and the delivery of benefit is lower than going from 2 to 1 with respect to the potential of children that you purchase from that action.
that's absolutely right. And so even though it seems low, going from, let's say, 3 to 1 will get you as much as going from, let's say, 20 down to 10. So
Exactly right.
And the other point that Sam and I both talked about is that even though 1 microgram seems low, it's almost 0, right? Well, that's really an artifact of how the metrics we use. For all the other metals, we use micrograms per liter. For lead, because it's so much higher in our environment, we use microgram per deciliter. So 1 microgram per deciliter is equal to 10 parts per billion. And there's a long way to go from 10 parts per billion down to 0, right? So it's a bit of an artifact. Moreover, we can, I didn't do this, laboratory scientists have looked at picomolar levels of lead in the forebrain of mice and found that changes down to that level result in stunting of the neurites in the developing brain of rodents. So even though we're close to 0 in the microgram per deciliter range, there's no reason to suspect that once we get down to less than 1, all of a sudden lead's going to be harmless. In fact, it's not. We can even see differences of 0.15 microgram per deciliter. You can see delays in the time it takes for a man to conceive a child, right? Down to levels of 0.15 difference. And so we haven't seen the end of lead hazards. This has been thought to be true for the past 50 years. It was lowered from 60 to 40. And then that was thought to be a normal level. And then from 40 to 30, then 30 to 25, then 25 to 10, 10 to 5. There's no reason to suspect that 1 microgram per deciliter is safe given all this evidence. Indeed, it's more likely that we'll find at lower and lower levels, down into the micrograms, down into the nanograms, that we might still see evidence of toxicity. And let me just contrast that. The levels that we're seeing, we're talking about causing harm to children around Reid-Hillview Airport. These are comparable with the concentrations that are in our blood from taking drugs, right? We know drugs are biologically active. We also know lead is biologically active at comparable concentrations in our blood. It should not surprise us. In fact, lead has been used as a medicinal in the past. It's toxic, that's a problem, but it was used as a medicinal. It didn't always work very well either. But there's no reason to be surprised by this, nor to be surprised if we see evidence at lower and lower levels, even compared to children today.
Can you please describe the effect on IQ with a lead level below 2 micrograms per deciliter? It has been said that there is no safe level of lead, so I'd like more detail on this low level region that has been omitted from the graph. Does it level out somewhere or does it continue up until?
To some extent, it's a function of the studies that have been done and the amount of lead in children's blood. We'll find lead in every child who's measured, so it's ubiquitous. And that's always been a problem, is that we don't really have a unexposed group. Everybody's exposed. When we get down to ranges in the 1 microgram per deciliter, there's 2 studies that have looked down at that level, the MIREC study out of Canada, and then a study out of Krakow, Poland. Now, of course, we also have animal studies. I mentioned one to you where they looked at levels in the nanomolar, picomolar range, but those weren't children. But what we've seen time and again is once we can find children that have lower levels of exposure, the problem is we've all been so heavily exposed, we still see evidence of harm. But so far, down to levels around 1 microgram per deciliter, we continue to see IQ decrements. The other thing I'd point out is that out of the 12 studies that have looked carefully at the shape of this dose-response relationship, right? All of them have found steep decrements at the lowest levels of exposure, whether they looked at blood, whether they looked at bone, whether they looked at plasma. All of them have seen the same pattern. And so it defies logic to expect that you're going to see this steep decrement down to the low levels around 1 microgram per deciliter, and then all of a sudden, nothing, right? It just doesn't make sense. But we right now, because of the amount of exposure that children have, the studies go down to about 1 microgram per deciliter. And if you send me an email, I can share the MIREC study and the Poland study with you.
Next question. What measures were taken in Flint to address the lead crisis there?
So, in the study that we performed, I can, in fact, share some telling graphics with you from that study. No, that's the. So this is the study that we did on Flint. And what I can share with you here is that the blood lead levels in Flint, in fact, returned to normal levels once the city switched back to its original water source. And that is evident in this graphic. This is the predicted child blood lead levels. This is before the switch, not in Flint. So this is the outer perimeter of Genesee County, sitting outside the water system. This is the before switch levels inside Flint. This is what the blood lead levels look like after the switch back in water source. You could see that blood lead levels returned to historically normal levels once the city switched back to its original water source. The city is also working through the slow replacement of something on the order of 27,000 galvanized steel and lead service lines. We have looked at the water lead concentrations in Flint as they undertake this lead service line replacement effort. And it's too early to tell if it's delivered genuine benefit in terms of the reduction in the lead concentrations in water. But that is one of the interventions by the city in an effort to limit this risk going forward.
Thank you. Based on your studies and experience, are the negative health effects from lead exposure long-lasting or lifelong?
I think that's an excellent question for Bruce. I think, Bruce, in your slides, you have that one compelling slide showing this long reach of early childhood exposure and the accumulation of lead depositing in bone that weakens life chances substantially.
Yes, there's several studies that show that it does result in lifelong implications. Sammy mentioned the study out of New Zealand where childhood blood lead levels not only predicted subsequent decline in IQ, but relative to their parents' social standing, the children who had higher blood lead levels fared more poorly than children with lower blood lead levels. So that was out to 38 years of age. David Bellinger, in a population of children around Harvard and Massachusetts General Hospital, showed in a long-term follow-up that childhood lead exposure predicted lower IQs in it was around 30 years of age, and we found the same in the Cincinnati lead study, as well as persistent increases in the rate of criminal behavior out to 34 years of age. And once again, you can see ranked exposures out to that time period as well. So the evidence is quite compelling. There's also laboratory studies of monkeys from the Madison laboratory that show if you dose macaque monkeys several years later when they're sacrificed, they are more likely to have the amyloid plaque that's consistent with Alzheimer's and dementia. So there's a number of studies that show that, and I'm sure there's others I could, if there's others out there, but they're not immediately coming to mind.
I'm reminded, Bruce, I think you were involved in this work in Cincinnati, in fact, looking at adults, comparing adults lead exposed as children versus adults exposed to significantly lower quantities as children, and examining volumetric loss in the prefrontal cortex and the angulated, I think it's I forget the other cortex, right? But there is known volumetric loss in these sort of fMRI studies that have been done.
That's right. And those were 23-year-old, on average, about 23-year-old adults. And we saw loss, particularly in the prefrontal gray matter, as with higher blood lead concentrations. We also saw that males were affected to a greater degree, that somehow women, it wasn't a significant difference, but the amount of loss was less in the young women than it was in the young men. And you can see that with other kinds of stress in laboratory animals, that women seem to be protected somehow. There might be some things going on with estrogen protecting from stress-related injury in the laboratory, and there's some evidence of that from laboratory evidence in humans, but that's more speculative. But we clearly can see, and then there's another study of about 9,000 9 and 10-year-old children, and living in a high-risk neighborhood for lead was associated with diminished cognition, as well as reductions and thinning of the cortex of the brain. So there's a lot of other types of evidence we could pull together, showing the long-term impacts.
What I find particularly interesting about these fMRI studies and the volumetric loss in the prefrontal cortex, right, is that this is the seat of executive judgment, right? This is the seat of sort of rational decision making, and the loss of that, you might assume, right, would implicate rational decision making, that persons exposed to lead, it stands to reason, right? As children, when they're adults, might have increased risk of impulsivity because of the loss of this ability to override, right, unemotional reaction to a situation.
That's right. And the prefrontal cortex is really that part of the brain that makes us most distinctly human. So it really is, to see damage in that area from lead exposure is quite important.
Thank you. And our final question for the evening, does a child that is born with a disability, are they at a greater risk of a negative impact of lead exposure as opposed to other children?
That's not a question I can answer with respect to the data made available to us. I'm sorry.
Yeah, there's not a, that's a very difficult question to answer because it assumes that you have some baseline measures of children. We did see in a recent study that we did in Canada that lead exposure along with phthalates made children who had more autistic behaviors a little more autistic. So in that case, we used a particular type of statistical analysis called quantile regression. Most of the time, we sort of assume that all children are impacted equally. But in this particular case, we can actually look to see whether children with fewer autistic behaviors or more autistic behaviors, for example, were more or less affected by a chemical like lead. And so we found that kids who already had high autistic traits were the ones that, given more lead exposure, became more autistic.
All right, everybody. We are at 9 o'clock, and I want to thank the researchers who have answered more than 70 questions this evening. We have more than 243 left. And
Goodness.
so what we're going to do is we're going to try and respond to as many questions as possible in writing and post to our website. So we have a county webpage, sccgov.org, and there is what they call a hero banner. So it's the banner across the top. It rotates, and there's arrow buttons on the side to have it force it to rotate. We have a banner dedicated to this airborne lead study. We have links to the study as well as links to this community meeting and one we have tomorrow night. You are invited to come back again if your question wasn't answered. We are trying mightily to get to all questions. And as I said, we will try, this is staff working with the researchers, to come up with written responses that we can post to this site for questions where there were some common themes. We will try our best. There was quite, as I said, a number of questions. Apparently it's grown to 247. Some were statements. I want you to know we're going to download all of this. If you made a statement, we're going to print it and make it available for our Board of Supervisors to consider as well. Thank you again for spending the evening with us. I want to extend my thanks to our Clerk of the Board staff, to Mr. Bruno, to our translators, to our American Sign Language translators. It was a lot of work, and we deeply appreciate it. We're very grateful to spend time with you and to answer as many questions as possible. And we deeply appreciate the great and avid interest in this subject. So good night. And for those of you who come back tomorrow, we'll see you tomorrow night. Thank you very much.